And we're live. Let's see if this is working. So I'm going to go ahead and share out the stream link. This is just a test stream to test my abilities to stream off of my Starlink connection, which doesn't work too well in terms of joining streams. Oh, I can hear myself. Need to mute my thing. So, okay, I muted my stream now. Anyway, yeah, I cut out every now and then, as you may have noticed if you've watched me on any live streams. So I want to test my ability to host on my Starlink connection. And in defense of Starlink, it is not Mr. Musk's fault. It is because I have trees in the way. But that's just the deal. So the question is not so much can you hear me. The question is can I host other people on the stream and not have it crash. So I have Luthemplaer here with me, and I mainly just brought him on just so we can just sort of shoot the shit about astrophysics and stuff like that, since he has some curious takes on these issues, and I think they're pretty interesting. So in case this goes wrong, no big deal, but maybe we'll talk about some interesting stuff. So anyway, Luthemplaer, if you want to introduce yourself or shill or whatever, go ahead.
Yeah, the artist formerly known as Cringewalker. I do a Telegram chat thing called the Restoration Bureau, mixture of my own and AI art synthesis. I occasionally write on Substack for at luthnight.substack.com. Uh, People think that the name comes from like Lutheran history, but it was really just a reference to Templars and Eleutherius, which is the Greek word for enlightenment, or more accurately, freedom. So I just think, free Templar, basically, kind of a name. It was a nerdy little thing, but yeah, I'm a couple creative endeavors. In real life, I do design and architecture and construction industry stuff. Not yet licensed. Hopefully, will be soon. Don't really have a lot of time to study it these days, but trying.
So one thing I've noticed about you is you have a very interesting mind. You have a very creative mind, which is not actually typical. I find in scientists and people interested in engineering. I don't know exactly what you do, but you've definitely done a significant amount of bioengineering, as far as I can tell.
Yeah, that's a side interest slash was a PhD candidate attempt. Then I realized that the school wasn't really willing to be science and more interested in the artistic stuff. So I was like, oh, okay, this is wasting my time. I got into biohacking, I guess you could call it. Probably back in 2019, early 2019. I was watching Thought Emporium, which is a pretty good YouTube channel for these like guidebooks on how to do this stuff. And the guy was doing this series of videos. He wanted to make for Halloween, I think 2018 or 2019, he wanted to make spider silk beer by means of having yeast produced silk. And he was planning on like fermenting the yeast and making a beer that had spider webs in it as like a bit of a bio nerd joke. But he hit a hard point where he wasn't really sure how to get the engineering working because silk is a protein sequence that repeats a lot and it repeats in such a way that it's very difficult to manually produce it. I'm going to skip over a lot of details, but essentially I wrote my own code. I think it was a Python script to generate the sequence that would be manufacturable. And I kind of let that sit on the back burner thinking, oh, maybe I fixed this. And about 6 or 8 months later, he made a new video saying how he resolved the problem. And it turned out to be the solution I was using. He had basically independently found it out. It took me about 2 weeks to figure out I could use a Python script to figure this out. He took a couple of months to do it manually. And that's when I realized, oh, so it's actually easier than I thought. I thought the stuff was like kind of like, oh, I don't have a specialty in the education background in this, so maybe I won't be able to do it. But that made me realize I could do it, which led to a COVID inspired. We had a lot here in New York when we started working from home early COVID days. We had a lot of extra time. For me, it was about 5 extra hours of the day without my commute. And so I spent those extra hours where I would have been in the commute doing nothing, sketching up potential bio designs and finding a lab to make them. I made a couple of prototypes of biologically produced materials. I sent it to a few PhD programs, got into one with a full scholarship. It was really nice, but it turned out to be not so scientific. And I don't know why they accepted me because it was in the EU, and the EU doesn't allow GMO research anyway. So like, well, well, I don't know why you decided to bring me to this program. So I left after like 6 months. I was like, this is pointless. But I still engage in those pursuits. I'm very interested in the potential, a few potentials there, be it producing biofuels, or biologically synthesized oil materials, which are there are a few ways to do that, and as well as building materials for architecture. Can you like make a microbe that can make a material that you can build with? They're really slow, but maybe they can be accelerated somehow in production.
Okay, yeah, so that's actually a good bit more about your backstory than I was aware of. I think it's clear you're kind of a hacker type person. Like in computer programming, what makes a really good hacker is this sort of inherent curiosity and creativity. I think you sort of have a reputation for being a bit subversive, but I don't really see it that way. I see you as always. You're very interested in uh, exploring avenues outside of like orthodoxy, basically. And I don't mean orthodox religion um, in a formal sense. I mean any type of orthodoxy, which does include religion. Like you, every stream I see you on, like just Settlers Lament stream, I think it was yesterday. You had some interesting takes on the LCMS stuff, and basically anytime I see you on a stream, you always sort of have these interesting takes that sort of go outside like the accepted wisdom. So what I wanted to talk about was just basically astrophysics, space stuff, questioning these standard models because I find that really interesting. Um, and I've heard you talk about how certain aspects of the Big Bang, as people understand it, may be incorrect. And interestingly, I don't know if you follow James Webb Telescope stuff and things like that. There have been some interesting developments in that area that actually sort of bring into question just how accurate this model is, and perhaps some of it comes from lay people misunderstanding what a Big Bang isn't uh, even is supposed to be as well. So I don't know. Do you want to jump on that and see what you can do with
Yeah,
it?
yeah, because our brains think in either 2D or 3D, almost kind of like 2.5D methods, and so when we hear Big Bang, we think it's an explosion of the universe. But you have to ask, well, like we're talking about the start of space time itself, and so if you talk about that, what are you exploding into and from? And these are difficult things to ask on current models because as far as we know, there is not an edge of the universe. It's merely that its volume increases over time and is increasingly getting so. So I don't think I don't think there's any consensus, but I'm fairly convinced if you kept going one way in the universe, you'd eventually end up back where you started. You can almost imagine it like the surface of a spherical world, but in like an extra dimension of space and time. Uh, they've done models attempting to see if quote unquote the universe is round or flat, and they keep saying it's flat, but I don't really know how you'd prove that. I'm not like an expert in this field. That you'd probably like you how would you prove the structure of what you live in is bent? You'd have to be outside of it to see that. So it's difficult for me to understand how you would prove that anyway. Um, the best way to visualize what the Big Bang is people have often used the example of the surface of a balloon getting bigger as you blow air into it. What's often left out in this example is that balloon surface is 2D. You're basically applying that in the third dimension. So imagine if you've ever played video games where there's like a seamless end and you cross into the edge of one side and you end up on the opposite side of the video game screen, like there's like a clipping effect where you'll you can't actually hit a barrier, you just kind of teleport to the other side of the map, and it becomes this infinite path you can go down. Think about that, but in three dimensions. So again, I like to think of it that I think, again, not proven any consensus wise, but it seems sensible that if you head one way, you'd end up in the same place because there really isn't an edge of the universe that's visible. There's just like a light speed barrier where it's beyond the speed of light plus the expansion of time, if that makes sense. So the Big Bang is essentially you start with a point of zero volume, and it expands into the current volume of the universe over time. And of course, it's supposedly accelerating. There's a big problem with this model, though, because under what we know now, space and time are the same thing, like the same structure, the same substance. So if you don't have volume, you don't have time. And if you don't have time, you can't have change over time. And so the Big Bang kind of self-contradicts, because in that first, like, t equals zero, the first moment of the universe, when you have a singularity, you don't have any time to allow an expansion. So it's like a self-violating model. There have been attempts to explain this with, maybe there was like an infinitesimally small amount of volume, or maybe there was like a perpetual volume. But this is nonsense, because the energy density of the entire universe would collapse into itself. And unless you're talking about the spontaneous creation of matter and energy after volume expanded, this too contradicts, because space-time is itself a form of energy that you can like extract energy from through like gravity and stuff like that. So it's basically a model that doesn't make sense at the start, and then it starts making. There are 2 points where the Big Bang breaks down. That point where space-time can't actually expand because time doesn't exist yet, and the second point is this weird like big expansion that happens. I think I remember reading somewhere around 300,000 years into the universe's start, where all of a sudden the universe expands very rapidly, faster than it is today, and then stops expanding and goes back to normal. And no one can really explain this. It's just this kind of like sudden bubble that appears and then stops.
So how do we quote unquote know that that even happened? Because people wonder, well, how do we even have any idea what was happening in the first 300,000 years of the universe?
Yeah, the universe, as far as I know, the universe is not yet accelerating faster than the speed of light, and so no matter how fast you're accelerating, you're still going to have the photon catch up to you. So if you look at if you look far enough back, you eventually hit this black void, which is like which I think it's around. Yeah.
What does looking far enough back mean? How do we look back in time, basically?
You leave a camera on exposure for an ungodly long amount of time. Right, so like the deep field, like Hubble and Webb are doing, where they just leave the camera collecting light for like months on end to see if any light is coming in, and continuously there's this like dark barrier that forms at around the estimation of like 300,000 years after the Big Bang, where there's just blackness. There's no photons coming from there. And this would suggest that the universe expanded faster than the speed of light to allow those photons to never have arrived here to start with. If the acceleration was below the speed of light, you would see light, because there's a black void at that point. If let me try to make sense of this.
Well, let me
Yeah,
take a whack at it real quickly, because what I was trying to get to is for people who aren't interested in this stuff at all. The further you look out, the more back in time you're looking, because of the time it takes for those photons to actually get from here to there. So if you look at something in the far distance outer reaches of space that it takes 13 billion years for the light to reach you, you're basically seeing what that thing looked like 13 billion years in the past, and this can give you some idea of what it used to be look. And that this goes in another direction that I think you mentioned on one of Burden's stream, is like whether or not, well, actually we kind of know it isn't, like time isn't even moving at the same rate everywhere in the universe. So how
yeah.
old anything actually is also kind of a weird question. But yeah, go ahead.
No, yeah. Like because space and time are the same thing, where space-time is contorted, time gets changed. This is why when you put an atomic clock in orbit, it goes a little bit faster than on Earth. The reason is because gravity slows down the clock speed of the universe. So the more closer you are to like density is not the right word. The more closer you are to a compression in space-time, the slower the time's going to go. So around a black hole where space-time is compressed so much that light can't escape, right? Like the speed of gravity has accelerated past the speed of light. Here time's basically paused, and so in many ways a black hole only exists because space-time can't actually catch up to the gravity, or rather the speed of light, and so it's just like it's a void that you can't actually get to. As a matter of fact, if you walk to a black hole's center, to singularity, and you somehow didn't like kill yourself from the tidal forces, you would actually not notice that time's going slower. You would see, if you could, the universe around you going faster. To your perspective, it would just be you're falling into a slower clock speed. So everything around you relative to you is going faster. I think that's the way it works. Yeah. There are like kind of like things that Hollywood tries to do this, like with I think it was Interstellar last time, where as they orbited the black hole, Earth was going faster. So like hundreds of years went by while they were just experiencing a few hours. That's the best that Hollywood can do. Just say like, oh look, everyone grew up from Earth because you were around gravity. But in the same way, if you're going to say the universe is a certain age, you first have to establish what is a neutral, like if we're imagining gravity as like a place where clock speed goes slower and a place in the middle of deep space where the clock speed's higher, you first have to establish what is the like neutral like speed, the clock speed of the universe. What is the natural clock speed of the universe without gravity? And this is difficult to say because of course we're in a Milky Way, which has its own gravity everywhere, no matter where you are in the Milky Way. So outside of the galaxy and outside of any galaxy in deep space beyond the any galactic perimeter, you're gonna have a higher clock speed on average than where you are here. And of course, to actually get an accurate model, you have to go there. So to kind of give an example of that, when a photon leaves a star in another galaxy, it's going very slow. Once it gets out of the galaxy, it speeds up because the clock speed's higher. And then when it comes to our galaxy, it slows down again. And over enough large enough scale, galactic clusters from their own gravity well, galactic, I think they're called tendrils or spider webs. There's terms for like larger structures in the galaxy.
Filaments.
Filaments, yeah. So what is the space-time compression of a filament? And the question comes, well, within our area of the universe, are we in such a huge gravity well that we wouldn't even really be able to notice the gradient as a photon travels through it? In the same way that like if you travel along a narrow enough hill, you don't notice you're going up like miles over the course of an hour. These are like things that are not really questioned. We kind of just take an average. Well, like where we are in the universe, space-time goes as fast as we see it. And around Jupiter it goes a little bit slower. Around the sun it goes a little bit more slower. Around Mars it goes a little bit faster. But there's not really a lot of like specificity in terms of figuring out what is the like quote unquote natural clock speed of the cosmos. Is that just an average, or is there a number regardless of the average?
Yeah, one of the interesting things too is I'm only a layperson in all this stuff. I just find it fascinating. But whenever I listen to these any like physics channels or whatever, they talk about how our models break down at like the singularity of a black hole. Like we can't understand it. Um, one of the interesting things is we have this, and I think this sort of ties into our culture generally. We have this heavy reliance on mathematics, but mathematics doesn't necessarily map one to one to physical space. Like just because you can demonstrate something in your mathematical system doesn't mean it actually exists in some way. One of the things I can't quite wrap my head around is what, as you said, a point with zero volume is even supposed to mean. Like this is what's supposed to be at the center of a black hole as well. This is a singularity, but what does it even mean to have a point with zero volume? The whole concept of zero space is very confusing to me. I'm not really sure if you quite can wrap your head around this either, or if it even really exists. Like, does that even really exist? And this sort of goes for particles too. Like, we have these particles are more or less like mathematical concepts and don't necessarily map to some like spherical tiny grain of sand as we sort of think of it. So what do you think of that?
I mean, yeah, like any center of a any center of a black hole where time comes to a pause. In theory, you can never really actually prove that. You're just assuming that, because if you could actually measure it, you would be violating the fact that there's no volume and therefore no time. Anywhere there's no volume in space, where space time has no volume, it also has no time. So in many ways, these are just like knots in the fabric of reality that very well may not actually exist past the light speed barrier. So like if you're standing by a black hole and let's say you're far enough from a black hole that the clock speed is the same as here, and at the center of the black hole, the clock speed's at like no time's happening, so it's like the clock speed's zero. In between that, you hit a point where the gravity is falling faster than the speed of light, and that's the event horizon, where you can't actually see past that point because no light and therefore no data can get extracted from it.
Yeah, and
Uh,
one of the ways I've heard this explained is not that it's basically that all of the lines lead to the center of the black hole. So because the singularity warps space-time, light just continues to follow straight lines basically. But the straight lines are curved, and they're curved so much that they only lead to the singularity once you get close enough to it. And this is why like, you can see stars behind the sun because the sun is also warping space. And the black hole just warps space so much that anything following a straight line, which light is doing, every line basically leads to the same point. Is how it works, from what I understand.
Yeah, sort of. But the problem is nothing in the universe is actually stationary, and so those lines are assuming you're starting from like a zero position. In reality, light itself is always traveling fast. So like, in many ways, the lines actually never hit the. In order for the line of your traveling speed to hit the event horizon, you'd actually have to be at absolute zero to start with. And nothing in the universe is at absolute zero, so nothing's actually hitting the event horizon. Once you have even a little bit of vibration, you're going to miss the event horizon because your straight line's off just a little bit because you have some acceleration going into it. So in many ways, you can't actually ever get to the event horizon. Some people have tried to model this with like maybe the knot in space time is actually uh just nothing, and over time it evaporates as the knot kind of works itself out from the very very slow speed of time around zero, and eventually at zero just like almost like heals if it even exists. These are people that they're basically afraid of the fact that their math doesn't work, so they're just going to pretend it doesn't exist. If the math can't cover it, it doesn't exist.
Yeah, well, speaking of that, dark matter. What do you think about that? I
Yeah,
think,
the Kabbalah black magic, right? Go on.
yeah, pretty much. I mean, dark. I think the layman understanding of dark matter is a little unfair because it's sort of just this turn of phrase. But I've sort of noticed over time that physicists tend to talk about dark matter as if it is particles. And like everything has to be a particle because all we have is mathematics that describes everything as particles. So there's this assumption that dark matter is like some sort of particle causing gravity, even though we don't even fully understand what any of these things are. And I it's just this interesting. There's this orthodoxy in astrophysics where it's just like accepted that dark matter basically exists as some sort of particle that's causing this gravity, even though there's as far as I understand it, no actual evidence that that's the case at all. Like apparently there are I think I forget what they're called, but you might know what I'm talking about. There's this complex deep underground that I think it's mostly used for detecting neutrinos, but I think
Yeah,
it
yeah.
also allegedly can detect dark matter particles, maybe. But again, it's not like you're getting information out of this thing, but what is like, are you actually detecting quote unquote dark matter particles with that? Or I don't know. Like
Yeah,
this is sort of too deep for me, but maybe you have something to say on dark matter because I find it's kind of just a huge cope for the fact that their models don't work.
it mostly, and dark things, and there's dark energy and dark matter. Dark matter basically means that the clock speed of the universe is slower than we would expect. Dark energy basically means the clock speed of the universe is higher than we would expect. That's really all it is. Um, and the way that works, there are some weird things that happen. So, for example, you know how galaxies are in the shape of a spiral, and if you have a whirlpool on Earth, the outer part of the whirlpool goes slower than the inner part. The part that's closer to the vortex is going faster, and the part that's on like more level water getting near the vortex typically goes slower. Gravities rotate all at the same speed, which is a really weird thing. So like no matter how far away you are from the center of a galaxy, it's all rotating at the same speed.
Oh,
Uh,
that's interesting. I didn't know that.
yeah, it's a really weird thing. Now there are a lot of simple mathematical things you can model that really make you question the age of the universe, because if it's all going at the same speed and you know the speed, you can actually count, of course, how many times has the galaxy rotated since the start of the universe. I think at some point I'm just pulling this number out of my ass. It might be some sort of similar, but at some point I did that with the Milky Way, and apparently it's only rotated like 50 times in the entire existence. And like yeah, a vortex forms pretty quickly in your bathtub, but I find it really hard that the Milky Way is only rotated 50 times, right? Like that's it, or something like that. I don't remember what it was. It was some number that just didn't really make sense to me. Uh, and you could do this with like almost any galaxy. Of course, if you go back to like the deep field imagery where you're looking at galaxies from like billions of years ago, they still have spirals. So you're telling me that the spiral, it's only rotated like once or twice since the start of the universe, which you can't see, but it still has a perfect spiral. That's kind of sus. Forgive my zoomer speak.
Yeah, that is interesting. I didn't know that about the rotation of galaxies. So no matter how much mass is in the galaxy, you're telling me they rotate at the same speed based on the distance from the center?
Well, every galaxy rotates at its own speed, but
Okay.
but the whole galaxy rotates at the same speed.
Right, okay, yeah.
And
Which doesn't make sense because the parts on the outside should basically get flung away at that point.
yeah.
Except
It,
they don't.
and so because they don't, they say that's dark matter because something is causing the clock speed of those parts of the galaxy to travel slow enough that they don't get whiplashed out. So why is it? And so they'll say, oh, every galaxy has a black matter halo, and what that basically means is that there's a halo around every galaxy that slows down the clock speed so it
Which
doesn't rip itself
I
apart.
see. That now your clock speed analogy or explanation makes sense to me. And again, the whole dark matter halo thing is literally just made up, as far as I can tell.
Yeah. It's like, why is the outer part of the galaxy traveling at the right speed, at the same speed as the center, and slow enough that it doesn't fling itself off? It must be just matter we can't see, dark matter. And this gets really like finicky with them trying to model like maybe it's a massive particle, like maybe it's a particle the size of a solar system that you just can't see. Okay, yeah, cope harder.
Or there's this other type of particle. I think they call them WIMPs, weakly interacting.
Yeah.
I forget what the M stands for. Particle. So it's a particle that doesn't actually interact with any other particle, so it can like exist and pass through everything, but somehow it also has mass and causes gravity. Therefore,
and a lot of what you're describing is basically a neutrino. So some people say it's just neutrinos. Or clouds of neutrinos, rather. Like a swarm of neutrinos would act like a WIMP.
yeah.
But
So what?
Sorry, go on.
One other thing that I've heard you talk about too is this idea of constants changing over time, like particularly the speed of light. M is massive in WIMP. Okay, yeah, that's what it was. Weakly interacting massive particles. So I've seen you post graphs on Twitter before about the speed of light allegedly being measured at different speeds, at different points in history, which is pretty interesting to me. And maybe there could be a number of explanations for that, like if the mass near us changes enough at like a broad scale, maybe that would affect how we perceive the speed of light on like a measurable way. So are there any other like what do you have to say on these changing constants, basically the whole concept of constants?
Yeah, and it's worth noting that like since basically, well, since the 20th century, there's been a lot of effort to make the constants self. How can I say, like the speed of light is whatever they say, and even if it's detected at a different speed, you're wrong. The constant's right. So like there's just like projection that goes on because again, like they're very afraid of they need these constants to work for their models to work, and so they'll make it like legally, basically like legally binding. You're risking your reputation if you question the constants. This is amongst the many reasons why I chose not to be a physicist, because I'm like, I know myself, I'm going to question everything. If I can't do that, I don't want to be part of your industry. But I posted an image, if you want to screen share it, of like,
Yeah.
there's a lot of like, this is like a very generic graph. This comes from some like 90s conspiracy website that I know the data comes from sources. I've never bothered to look them up. I've seen them mentioned by different people, but I can't be bothered at this time to actually go into it. But yeah, I mean, like in the 1800s, there was a very wide range of answers in terms of like the speed of light, and then by the 1900s, 1920s, this number gets fairly constrained. Like as the accuracy goes up, the exact number gets more figured out, and then all of a sudden, everyone doing these tests detects a drop in the speed. No matter where you're testing, no matter what equipment across the planet, the entire the detected speed of light drops everywhere. So you would expect, as you're getting more accurate, you'd find more accurate models. Your range of data gets more constrained to the same numbers keep coming out, as you get more accurate. And then all of a sudden, everyone discovers, oh, we're all wrong. It's actually a lot slower. And then comes the 1950s, and as the even though that shift occurs, accuracy keeps coming in. The constraint of the number ranges keeps getting smaller. And then around 1950s, everyone detects, oh, it's actually faster. No matter what equipment you're using, no matter how exact it is, everyone detects a small increase. These are increases and decreases of only like I think 2 kilometers a second. So like fast, but like when light's traveling 300,000 kilometers a second, a 2 kilometer difference is like, it's big for a human, but not for the speed of light. These changes are generally hand waved as, oh, they were just getting more accurate, but that's kind of not great answer, because if you're getting more accurate over time, your numbers would just continue getting more smaller in the range of answers that they're putting out until you got like a basically an exact figure. You wouldn't have a universal shift regardless of new or old equipment being used. That suggests a change in the constant, not in the equipment that you're using. Um, these things have been detected basically twice in the last century. The speed of light dropped suddenly in the 1930s, then rose suddenly in the 1950s. Maybe that was just a really massive gravity wave that Earth was going through. I don't, yeah, here you go. So if you zoom in
There we
on
go.
that,
I finally figured it
dollars.
out.
So like, yeah, in the 19th century, you see these wide
Is that working?
ranges. Yeah, yeah. This comes from some 90s conspiracy website book. The sources are real. The guy writing it's probably full of shit. But like in the 1800s, you see those wide ranges of numbers, and they're getting pretty wide. And then around 1900, there's a sudden drop. But then the range, the range of numbers you're getting is getting smaller, but the location of the range shifts. Right? Does that make sense? Um,
Yeah. So is that like our instruments are getting better, which is why the ranges are wide?
Yeah,
Or
yeah. So in 1800s, the way you measure the speed of light was like spinning something really fast and seeing how quickly the shadow showed. There's a whole bunch of convoluted ways of testing it. Around 1900, they started doing much more accurate methods. But like you see in 1900, even though the range of the speed gets smaller, it entirely shifts to a different area. And then by the 1930s, your range of answers is getting smaller, but shifts. It doesn't really shift, but it shifts more lower than upward. And then also in 1950 or so, the range gets really small. Like the range is now within like mere meters per second, but it goes up. The answers you're getting are getting totally up, and many of them are higher than the ones you were even getting in the range before. Um, and then it just kind of peters off into what we have now. And of course, by the 1980s, people no longer test the speed of light. They establish a fixed number and just assume it. So the speed of light might be changing by 2 kilometers a second even now, but we're not measuring it anymore. It's just an accepted number now. It's been established as like a international standard. And so always be suspicious of science that decides to go off of a constant instead of a measurement. Constants are useful for generalizing, but if you're going to do like hyper specific tests, you probably should test your constants as the fact we haven't tested the speed of light value in like 40 years is really suspicious to me. It's just like, no, we're not going to test it. We don't want to know if it changed. We're just going to assume light speed is the same as it was that we found in the 1980s. That's it. Done.
yeah, and well, the thing is, because of how the speed of light can be locally affected by
Gravity.
yeah, it would make sense to check it because it could just change locally. It's like, how do you even know what the absolute
Well,
constant is?
locally, you wouldn't notice the change. If someone was looking at us from another star,
Oh
they would
yeah,
see a
you're right.
change.
You're right. I forgot that's how it works. Yeah, this
Yeah,
stuff is
it's
really
hard. Yeah.
weird. um,
It's like
hmm.
you. So that's why it's weird, because like you locally would not notice a change. You locally would be in your own clock speed, and the speed of light would always be what it's supposed to be. The fact that it's changing like that in terms of the ranges that you're getting is extremely suspicious. Because it really shouldn't be. If you're looking at like a star system light years away, it's okay to get like totally different ranges because the clock speed might be changing over there. And like you have to be outside the system to notice its changes. Basically, the principle to go by is like, in order to notice a change, you have to be outside the system that's observing it. Um, and that brings up questions of like, well, like we can't see the edge of the universe, so we can't actually see outside of ourselves. So there's this joke I like to say. Um, if the first black holes of the universe formed on like the first couple of days that the universe happened, there very well could be a part of this universe that literally is only like 6,000 years old, because it would have like compressed into a small portion of space time and just stayed at a small clock speed till this very day. Uh, I can basically go off of this and criticize both young and old Earth creationism here, because both old and young Earth creationism assumes that the age of the universe is constant throughout the entire universe. Neither of these people want to bother questioning like the facts of relativity, and that kind of just makes them both look dumb, honestly. But anyway, sorry.
Yeah, no, that was something I wanted to get into, is the young Earth creationist angle, because I heard you mention that, I think, on one of burn-in streams. Do you want to explain that in a bit more detail?
Yeah, I mean, I used to be an old Earth creationist, or evolutionist, whatever. When I assumed, when I didn't question these models, but now since I've questioned them, I'm like, well, for all I know, like in the same way that God made Adam and Eve, like probably 20 or 30 years old, Adam and Eve are both like 20 or 30 years old and 0 days old on the day that they were created. So people are like, well, why would God lie by making the universe look old? Like, I don't care. God made the universe as it was, and then that's the way it is. Or he made the universe as we think it is, but it wasn't actually 14 billion years ago. It just space time had another big expansion that we haven't noticed yet. I don't know. Like these questions are meaningless to me now that these things happen. So if they're meaningless from a scientific point of view, I might as well just go for tradition instead.
Yeah, and I guess the problem with questioning any of these things is people look at you like you're crazy, even though the scientists themselves sort of, if you really, if you, it would be really hard to get one to admit this, but they actually are not certain at all on things like the age of the universe because of a lot of the things we just talked about. But like you said, there's this orthodoxy in science where you can't question particles, you can't question these constants, you have to work within these standard models, and if you don't, you're some sort of conspiracy theorist. And I think it's really because, I mean, I think it's because they can't at this point tolerate having their fundamental model of physics questioned because it would cause serious problems in terms of the general atheistic epistemology. Um,
Yeah, one of the probably the early parts of me starting to be really suspicious of those models was when people started getting like autistic about uh quantum effects. I forget the term, like the Schrodinger's cat model, which to me is just is straight up a research fraud. You'll have these guys like entangle particles and then separate them by like miles, and then look in one box and say that the information teleported to the other one. But how can you test this? Like there's this idea that if as long as you're not looking at the model, the information was teleported instantly. This is just bullshit. This is just like, oh, we've discovered something that goes faster than the speed of light. No, you didn't. You just didn't look in a box. That's all you did. Nothing teleported. The information was already predetermined when you entangled the particles. Just because you looked in one box and now know what the spin rate. These have. Sorry, I didn't explain myself. Entanglement means you basically make two particles spin in a relational way, so that if you know the spin of one, you know the spin of the other one. And they'll say like, oh, we know the spin of one because we open up the box. The information of that spin transmitted instantly to the other particle because they were entangled. No, bullshit. Sorry. They were already predetermined after you entangled them. You looked at one, you use logic to deduce the other one must be the complementary spin. There's no instantaneous communication that happened faster than the speed of light. The information was transmitted when the particles were close together and they formed a relationship in their spin. Looking at one doesn't make the information teleport to the other. This is nonsense. And of course they just hand wave it. Oh, but like, we can't see. If we look at it, we violate the entanglement because you're using you use a photon to observe something, and so that ruins the entanglement because it's interacting outside of its system. Like, so what you're saying is that you close the box, and if you look at it, you ruin the box, and it's just magically teleporting because you don't want to look. You're pulling my hand, like you're pulling my leg. This is bullshit. You just want research scam money.
so I'm looking at your article here that you linked. I'll actually just post it in the chat here real quick. What can we go through in here? So you talk about the. Well, why don't you pick one that we haven't talked on yet?
Oh, yeah. So we're going into why there's probably no aliens.
Is okay. My thoughts on the.
Oh, before we do that, there was one comment that I saw about
Sure,
atomic decay, because decay rates are usually the way you prove the age of the universe locally rather than speed of light. There's a minor problem with decay rates. It's been observed now that solar flares do wiggle the decay rate. So every time the sun has a solar flare, the decay rate kind of accelerates a little bit. Not a huge amount, but then again, we haven't really been hit with a huge solar flare, so we don't actually know what a huge solar flare hitting the Earth would do to decay rates. We haven't observed it. If at some point in time some like massive solar flare hits us, and like disabled half the planet's technology, and like we're in havoc for a few months. Hopefully someone's looking at decay rates and sees, well, I guess we were completely wrong about how fast things decay. Atomic decay is treated as like this fixed constant that things always decay at a fixed amount to their half-life, radiological decay, and there's no questioning it. But data shows that it wiggles a bit, and perhaps, this is again speculation. It's not true, but if our assumptions of that get disproven the next time a big solar flare hits us, we're kind of fucked in terms of dating things in the fossil record, because that means it's complete nonsense.
Mm-hmm.
Okay, we can go on to aliens now.
No, that was really interesting though as well. So okay, I actually forgot about this, but I have an article on Old Glory Club that's not published yet about the Fermi Paradox, which I'm very interested in.
Oh yeah,
The so-called paradox. It's not a paradox in my opinion. So I need to publish that at some point. But my take on aliens is there are no. I think that's the sensible null hypothesis at this point. There's literally, okay, there's no evidence whatsoever that aliens exist. Period. Okay, don't talk to me about these pills or whatever the hell's taken off in aircraft carriers and oceans, and the Americans are seeing on their radars. Okay, that's just a bunch of nonsense. I don't care about that.
yeah.
If
Half
you look
of
out
them
into the
have.
sky, yeah, no, you go ahead.
No, like there was this video of triangles flying around from a night vision on an aircraft carrier, and a lot of photographers proved that this was just someone using a triangle shader on the camera. And there's the video of the balloon traveling very quickly that they thought was a UFO, and some experts did some mathematical models and realized it was traveling like a few miles per hour. It's a balloon. It's not actually like some hypersonic nonsense. There's never been anything interesting in terms of what the Air Force tells you, or maybe the government tells you, I should say broadly. And pretty much every example, it's been proven to be just the government fooling with you. They just want you distracted. There's nothing spectacular. There's literally only one unique phenomena. It's ball lightning, and there's no evidence it's like an alien intelligence. It may just be a natural phenomenon. I've seen ball lightning. It does look really interesting. One of my friends got ball lightning went into his house and shocked him like a spear, and it like hit him and like made him like get freaked out. These things happen. Like, maybe it's a ghoul, maybe it's a ghost, maybe it's a demon. Literally, a demon is more believable than aliens coming to just like poke at you and disappear into the void. Right? This is nonsense.
Yeah, I actually agree with that take. And again, final take on this part of aliens is I don't care about Area 51 or whatever nonsense. This is not relevant. The point is, you look out into the cosmos, and there is absolutely zero, zilch, no evidence that there is anything out there, that the universe is anything other than a cold, dark void, with the humans on Earth being the only life with quote unquote intelligence. I don't want to diss the animals, obviously, but Earth is the only place that there is life in the universe, period, as far as we can tell, based on all evidence, which is obviously how science should work.
Yeah, and even if we find like pond scum on Europa, there's no reason to not believe that that's just something that fell off of our planet from an asteroid strike and fell there.
Exactly.
There would have to be a fundamentally different methodology of living, like something other than DNA, for it to be properly alien. If you go to Europa and that red slime that's on Europa turns out to be cellular life, if it has DNA, it came from Earth. I'm sorry, but like I bet you if you tested the DNA on it, it would basically look like pond scum here. I'll go into that more later on, but sorry to cut you off there.
Yeah, well, that's not even a weird take, because we know that there are asteroids from Mars in Antarctica and probably all over Earth that, so the planets pollute each other all the time. So yeah, any other life in the solar system is just it's highly unlikely to be its own unique genesis. And well, if you notice too, and this is really stupid, is they're just obsessed with searching for life on Mars, which is just an obviously dead world.
Yeah, it's like a radiation-soaked hellscape.
This is why, if you remember, I asked you a while ago if it was possible to like send bacteria to Mars to like populate it, because honestly, I think that I think some dark academia university should fund like a secret CubeSat to Mars and pollute it with bacteria just to like screw the scientists, because I'm so tired of this nonsense.
It would only cost $1 million to do that. You probably do it for 800,000 if someone wanted to like crowdsource it to troll academia. You could do it.
Yeah,
It wouldn't
exactly.
be hard.
No, it wouldn't be hard, and you wouldn't have to say what you were doing.
Yeah.
Like you could just hide the bacteria in your stupid satellite and just start terraforming Mars and just end this nonsense of looking for life, looking for drops of water underneath the desert with these stupid, dumb little robots. I mean, what we're doing is just so stupid. I can't wait till Elon Musk sends some actual human beings to Mars. For the love of God, and just colonizes the place because it should be colonized, and it can be, despite all the problems of the radiation and whatnot, because underground exists. But no, they're obsessed with finding life there because they want to disprove that God exists or whatever. So anyway, that's my rant on Mars. But yeah, if you look out into space, you don't see anything, and the scientists are always just coping. They're always coming up with all these weird explanations, some of which are interesting, especially the one in the book you and Burden just reviewed, or the series where basically you want to hide because everyone's out to kill everyone else, which is probably the most likely theory. But the thing is, like, you would still expect to see something, right? And we just see
Yeah.
nothing anywhere we look.
The if you want to get into what I wrote in that article, the
Yeah.
big one for me, the biggest, most glaring, like, there are no aliens evidence is the lack of what's it called, spectronomy. I use the word spectrology. Whatever light hits something, it takes data from the thing it hits. It changes color, it shifts. That's why when you like shoot a scanner at something, the light that comes back, you can get data off of what you're scanning. Like photons are sticky with what they touch, because when a photon hits something, it basically enters the molecule, and comes out with, atom, I should say. It enters the nucleus of the atom, or the electron going around the nucleus, and it like will encode like almost like data from that. So like with photons, you can encode electromagnetic data, you can encode color data, material properties, because it's color. Color is everything has its own unique color. Everything can be, you can find out what something is made of by looking at the color that comes out of it. For all the cosmos, you can do this to figure out what's on another planet by just reading the data from the light coming from the planet. So if you put something in orbit so that our atmosphere doesn't influence that data, the orbiting satellite can detect like material compositions from the atmosphere. The terrain is a carbon based, silicon based land on the planet. You can figure out, they've done things like finding out that it's raining diamonds on a gas giant 100 light years away, because they can see the carbon data coming out of the photons. That like there's the same chemical signature as carbon, as diamonds coming out of that carbon. Because not only does the material properties give off data, but the way in which the atoms are arranged can give off data. This is why photovoltaic cells work, because it's like taking in a piece of the data from a photon and then spitting out like a reflection. There has been thus far zilch spectrological data for photosynthesis. Photosynthesis is done through a series of well-documented molecular processes. Each one of these has their own spectrological data lines that when the light hits a photosynthetic cell, it outputs a series of chemical signatures. Most obviously the color green. The color green is a big signature because that's basically what photosynthesis looks like. But if you look at the green color itself, it has several data lines that within the light spectrum.
It's not that it's outputting green so much as absorbing.
Sorry, my bad.
Important distinction.
Very important. In fact, the opposite of what I said. So like, if you put a camera to an alien planet that looks like it's in a Goldilocks zone, and you want to see if it has life, you'd get photosynthetic spectrum lines to show. I wrote in my article specific lines, and this comes from a blog, Centauri Dreams, a great blog from like the 90s and early 2000s that's still active. Just like a bunch of astronomers that are just spurging out about why there's probably no life, and like all their little collected like decades of life experiences of why they think there's no life. Or if you actually wanted to see if there's any life, how you would do it properly. And this whole thing that they've been doing is a pretty big reason why I don't believe there's aliens out there, because there's simply no spectrological data that says that there's photosynthesis out there. And I'm sorry, but like photosynthesis evolved on this planet. If you're going off of a Darwinian model, there's like 6 or 7, maybe it's 5 or 6 different incarnations of the photosynthetic molecule. It's not one molecule. There's multiple ways to do photosynthesis, and each one has its own chemical signature. And these things supposedly have evolved on Earth multiple times from independent cell lines. It wasn't just one first cell that made photosynthetic food. It was several cell lineages that developed it independently. So this is like it seems like life is kind of like pre-coded to develop these things because it's done it so many times on Earth. None of it shows up in space. No matter what planet you look at, no matter what area you look at, none of this shows up. Even like hypothetical nebula cells living in like space soup, nothing. There's nothing like it. So there's what am I supposed to believe, that there's simply no photosynthetic cells out there? Yeah, if there's nothing being found, there's just nothing. There's no plant life. So that was a spurgy argument. But
well, it doesn't even have to be plant life. It's algae does this, right?
Yeah,
or bacteria even. So
literally
you don't even
anything,
have to-
like anything that uses the sun, anything that uses light for food makes this chemical signature, and there's none of it no matter where you look.
Let me highlight one or two things in chat. So someone mentioned this.
Oh, Charlie cut off. Elon Musk cut him off.
Okay.
Oh, you're back.
Interesting. Okay, so yeah, this comment here, interesting avatar, by the way. What I'm talking about is the whole cosmos. I mean, I'm willing to extend the lack of aliens appearing anywhere we can see to literally everywhere, and anything that you would call creation or everything or the universe or cosmos, whatever word. I'm gonna say that the only life is from Earth. Period, as far as I can tell, and I think that's the null hypothesis. Would you agree with that?
Yeah. I mean, like I said, like let's keep a broad church approach to this. Like literally anything that will take in food and output like metabolism, if that makes sense. Like I'll keep a broad church. There's life, okay? Other than geological activity, there's life. Can't find it.
Okay, and then we have this. I have my own thoughts on this. Do you have an answer to this question or this point? Let me just say it. Why would God create this vast universe and only create life on Earth? Pretty pointless.
I think it's pretty much means that the universe is for us. So
yeah, I mean, I don't see the issue. I mean, people will bring this up, right? And it's like, well, why would he create all this wasted space? It just doesn't make, it doesn't make sense when you're talking about an omnipotent being.
Let's rephrase that, right? So like first humans, wherever they evolved or were created, if you we'll go with both models, Darwinian and gospel. Wherever the first humans were created, why did God create such a big planet that was empty, right? To fill it up.
Yeah, pretty much. I mean,
it's a dumb argument. It's no offense to you, but like if God real, why thing big is a really dumb argument.
Yeah, exactly. I mean, it's doesn't really address any of the things we're actually saying here. I mean, yeah, I think you've said everything there. Okay. So, all right, we're coming up on about an hour. I don't want to belabor points. I'm kind of running up against just any other random things to bring up. Is there any more spurgery you want to do that we haven't gotten to yet?
Well, I mean, what are some of the things I brought up in that article? Let me go real quick.
I think my main goals, while you look, have been accomplished, which is I seem to be able to host a stream and not just have it totally crash and have a guest on. And I mean, look, okay, so we have this guy saying, again, do we understand the difference between our galaxy and another? Yeah, we do. I mean, we could also see other galaxies, and we don't see anything going on there. And our galaxy is certainly plenty big enough to have multiple instances of life in it if it was like a thing that ought to happen. I mean, you could disagree with that, but also we can look at other galaxies and there's nothing there. Okay.
The other thing that I only learned this last year, but Earth's mineral diversity is primarily a result of the influence of life. So like a lot of the kinds of rocks you find in the Earth are a direct result of life's processes. So for example, in Germany, there's this massive copper field that you can mine, and I think the copper within it has certain properties as a result of Earth having so much oxygen in it. There's dozens. I think Earth has like thousands of mineral species of like of rock. They call it in geography. They call it species for some reason. And only Earth has these species. No matter what planet in the solar system you look at, many of these species are dependent on the existence of life, and you don't see them anywhere else in the solar system other than Earth because Earth has life. Likewise, those mineral species, they have chemical signatures. And so in the same way that you could use chemical signatures to find photosynthesis on another planet, if you weren't looking for that and you want to go more broader, you could look for the minerals that form when life is present on a planet. And maybe the planet got blown up and it's just like, smeared those minerals across a cosmic dust cloud. Maybe there's just a cosmic dust cloud that never formed a planet and those minerals formed from life there. No matter where you look, you can't find those minerals anywhere else but on Earth. Those are wholly unique, life-dependent minerals, and you can't find them anywhere else but on Earth. So therefore, Earth only has life. That's probably my final point on that topic.
All right, and I'll just bring up one more thing from chat. I mean, we can still see that there's not cosmic tier engineering happening in other galaxies. That's something we can see. And I mean, look,
mass spectrometry, that's from Half-Life. Mass spectrometry is not. I don't think mass spectrometry is real. That's a Half-Life reference. But regular spectrometry, when you're using like stars in other galaxies, I mean, I think that's true. But at the same time, there's like plenty of planets within our own galaxy you could scan, and there's like literally nothing. And there's the whole idea of like the explosion of life. Once life gets intelligent, it tends to just explode rapidly
exactly.
in advancement.
So that's why I think points like this don't really land for me either, where it's like, oh, we haven't looked anywhere. Well, it's like, okay, if you look at, again, taking the example of Earth, if you look anywhere at Earth, there's life everywhere. So it shouldn't, if there's life in the universe, it should expand pretty quickly. I mean, of course, the other argument is like, we're just really early and, other people haven't developed yet, but I don't find any of this convincing either. I think you just have to me, you have to go with the null hypothesis, which is that we're alone, because there's no evidence for anything else. Okay, we don't have statistics on the development of life. We don't even know how it actually starts in the first place. I mean, the whole concept of abiogenesis, of life just sort of spawning from like molecules bouncing around volcanic vents and stupid stuff like this, is just kind of ridiculous in the first place. I mean,
there's also the fact that we can model life-like properties of like bubbles forming pseudo lifelike systems on Earth in a lab with molecules bouncing around, but like going from there to like DNA is quite a hell of a jump. That's like a massive fucking jump, and that's why you don't really see it anywhere because it's
I mean, this whole thing is just kind of written off, like where these proteins came from and how they formed into these double helix molecules. It's like that is an enormous, or RNA first is the thing we go with, but still, that's a huge jump for it to go from like amino acids sort of connecting with each other to forming this complex self-replicating system. I mean,
and because people will oftentimes say, oh well, like amino acids will eventually form an RNA chain. Yeah, but that RNA will be very, very randomly assembled and oftentimes not really be very readable. You also have to have the molecular engineering to read and write DNA and RNA before you have RNA and DNA there. So it's kind of like there's a lot of evidence that it even if it evolved, it doesn't seem to have evolved in the order you would have expected from like assembling random blocks. Anyway, there's another comment there.
Yeah, well, I mean, the comment's just wrong because there was evidence for bacteria and viruses, and that's that bacteria and viruses were killing people.
Well, also, there's Marcus Varro's on agriculture, where he basically developed a very primitive microscope and documented microbes. That was in the Roman era. Not very well known because people don't read ancient texts, but I do. And Marcus Varro wrote about, I'm going to quote him verbatim: "Don't build a house by a swamp, for there are small microscopic organisms that live in the moist water that will transfer to your lungs through the air during a wind and infect you." He's using modern biological language because there are methods to develop very simple microscopes with literally just water droplets and fire and like a stone with a hole in it. You can make these with like your own tools around the house. And it was not difficult for these people to discover microbes. And there's a whole lexicon of microscopic life in the Roman era that they were discovering. And then they just kind of were like, we can't really do anything with it. So it's just a thing that exists. And then it kind of gets forgotten about by the Middle Ages. Yeah.
So I don't know if people aren't understanding this, but we're not working for this argument because we do have the tools to look, and it's not there,
Yeah.
right? I,
Again, like even if life was incredibly rare, if it was successful, it would spread very far, very quickly once it was established. And I'm not talking about within a planet. I'm talking about intelligent life spreading throughout a galaxy. It only takes 200,000 years to go from one side of the galaxy to the other. You could colonize the galaxy in less than 1 million years, and the universe has been here for 14 billion years. So like, where's the even like the dead civilizations? If a civilization died, where are the like space-time trails of light ships traveling by? Where are the chemical trails of old-fashioned rocket ships traveling by? Where are the Dyson spheres as a classic one? Where's the
exactly.
evidence? Like where are the fields of starship battles, of like dust clouds of metal and complicated machinery that you'd be able to detect from like clearly artificial materials? Where's even plastic in space from thousands of years of civilization? There's nothing.
Yeah, and I mean, I'm totally open to there being aliens. I'm not like trying to be like they definitely don't exist. I'm just saying your default has to be I don't like people actually believe that they're out there for sure, basically because of statistics or
Yeah.
probabilities or something. But I
You
think that's
got
the wrong way to look at it.
Chris Judson says nobody in the ancient world knew about exoplanets. They wrote science fiction about it. One of the the first science fiction was a Roman story about going to the Venus to witness a battle between the Venetians and the Solar people. The writer said this is a fiction, but like they understood the concept. If you can go back even further before the Roman period, in the Greek period, the Book of Enoch from like 200 BC or so. Enoch goes traveling to the Palladian star system and describes them as fiery mountains in the void, with neither a heaven above nor an earth below. He's talking about outer space. These are concepts that were well established in ancient times. They weren't popular, but they existed.
So this comment, I get this from like a scientific perspective, but people don't actually act this way. You can't like act in ignorance. You always have to act based on probabilities, and the probability is that we're alone. So we should act as if
Yeah,
we're alone
I
until proven otherwise.
if we couldn't read the spectrological data, the electromagnetic data, the neutrino signals, with all the many manifold ways of scanning something, then we wouldn't know. We can do these things, nothing shows up, so we know that there's no life. Or at least there's no current life. Maybe there was some hypothetical civilization that had its era and died out, and all the light left over is already gone. But again, I would say you'd at least see chemical signatures of that.
Yeah, and I'm like I said, I'm very open to it. I mean, if you
That'd be great.
showed me one literally anything like that you just rattled off there from the list, I would be pretty easy to convince. I mean, obviously, it would be really cool if there were aliens out there. It's actually, that would be interesting, right? But it looks like there aren't, and frankly, I just think it's wishful thinking to imagine that there are because it's just not there, guys. It's not there. Obviously, this is controversial. A lot of people disagree with this, but yeah, honestly, I don't understand why it's such a controversial take.
Yeah, and if we're wrong, it's not like it's religion. Okay, we're wrong. We were wrong. Oh well, our models were wrong, like we think your models are. Okay, I can admit that. There's nothing
Yeah.
life changing. If aliens decided to come down and say they existed, like I wouldn't feel shamed or wrong for going off the data I had. Be like, okay, new data, I was wrong. End of story. It's not like some don't build your personality off of proving something as ridiculous as is right or wrong. It's dumb.
Yeah. Okay. So I think we've kind of covered over everything that I wanted to there. Unless there's anything else in your article you want to cover, but yeah, as far as I'm concerned, the stream was a success. So, yeah, are you ready to be done?
Yeah, I guess
Cool.
last comment from Chris Jones there. Any aliens would need to travel faster than light to get here. Physically impossible. No, you can just make a higher clock speed by using dark energy or whatever. Like you can cancel out a gravity wave and form a negative gravity wave, a positive wave, if you will. And your clock speed would increase and you'd get faster. You wouldn't be traveling faster than the speed of light. The space time around you would be. Like it's an Alcubierre drive is what it's called. You can do this.
Mhm.
We've detected these kind of waves. The recent gravity wave telescope detected this. Like this is a reality. Gravity waves are the inflection of space and time. So it would yeah, maybe on the ship thousands of years would go by, but you would get to the next planet in like a few years. So it'll be a generation ship, but it'll only be for your local space time. So this is also nonsense.
So
and such a ship that did that would leave behind a gravity wave wake that you could see for like basically the entire universe. There are no gravity artificial gravity wakes. The only wakes we see are from black holes and large massive items colliding with each other. If there were aliens, you would see these gravity wakes from small minuscule pieces going at very like you would see wakes of gravity in the direction between stars for clearly intelligent travelers. Instead, they're just random from collisions in the center of galaxies usually. So it's like it's another nonsense argument. Sorry, Chris Johnson. I can do this. I can do this all night if you want, but we gotta go. We gotta go.
yeah. So to TLDR what he said there, in case that doesn't make sense, basically the way we think you could make an FTL drive, if it's possible, should leave effectively waves like in the ocean that you would notice. So there would be, you would see, and it would be waves like, if you look at waves from a boat, like a human can tell what artificial waves are, right? Like if you just look at water, you can always tell. So there should be some evidence like that. But yeah, anyway, don't get mad about this. This is just this is a throwaway topic. I just thought it would be an interesting thing to tackle in case the stream failed.
Yeah. Well, it seemed to work. I mean, you only had like a few seconds that broke up, but it's working pretty well. So Starlink's getting better.
Yeah, no, this was good. So yeah, my last video is gone because I don't know. YouTube doesn't like it for whatever reason. So I need to upload that to Odyssey. But on this topic, the reason I wanted to do a test stream is because I'm now going to plan an actual stream with Todd Lewis on the Praise of Folly show because he has been doing some really good videos, sort of debunking Moldbug, basically, with a
spicy
buddy of his. And so I want to invite him, Dave the Distributist, and Closington on to my channel to basically just have him talk about it, talk to us about Moldbug. And, you know, my thoughts are we're basically going to either defend him, agree with Todd, or just sort of explain things to help Todd, I don't know, understand better. I just kind of want to talk it over because I think what Todd Lewis is doing on Praise of Folly, is the channel name, has been really interesting. What does he call his series? Let me check it out real quick so that people can find it. It is called Control F, grind set stream, escaping the Moldbug matrix. So yeah, there are a lot of these episodes now. So if you haven't seen them, maybe catch up because it's really interesting stuff. So anyway, be looking out for that live stream. Hopefully in the next like week or something. We'll see. I have my own issues here at the moment I'm dealing with. Specifically that my water pump broke. I think it might be working now. I think it might have frozen overnight. So hopefully in the next few minutes I go flick the switch and it just works fine and I can bathe because I'm stinky. And when you don't have water, that's what happens. So wish me luck there. Send some prayers, whatever.
Yeah.
Not a big deal.
So in the comments recommended Jaws, who's an actual, I think he's an actual physicist in our tangential circles. He'd be a good guy to bring in some other time.
That could be interesting. Maybe we'll do another stream on this. Again, I don't know the math. I'm not a physicist. I'm interested in the topic. And there seems to be a lot of bollocks in the topic, to be honest. Just like the way I have a huge problem with the orthodoxies of all these things. But anyway, thanks for coming on. Look out for that stream I just mentioned in the next couple weeks. Do you want to show anything again before we leave?
Yeah, I mean, Restoration Bureau is ongoing at Telegram. I think it's just Restorationist is the Telegram link. And I'll hopefully I'm writing something right now on Substack about quote unquote the political zoo. That's a term that's been going around a lot now. I don't think people realize that's from the early 2000s. It's a really nice term. I have a few Substack articles I want to go back to writing. Now that I've like streamlined a lot of the Restoration Bureau stuff, I want to get back to writing my own thoughts down. Yeah, that's about it for now.
Actually, Stinky is the name of my satellite dish. I forgot that. All of your Starlink dishes have names, and mine is actually named Stinky. So that's kind of funny.
Oh, there's Jay Burden. Hi, Jay Burden. Anyway, thanks a lot for bringing me on. It's always fun to autism about this topic.
Yeah, for sure. All right. So with that, I will see everyone later. Bye bye.
Bye.
Oh, I'm gonna leave and leave you alone. That's the wrong button. Need to hit end.